Welcome to this Trimble Business Center video tutorial. In this video, we will cover the block configuration and the control point distribution. So let's start with some theoretical parts. You can skip it if you want, but just that we are aware what to take care. So a recommended configuration typically would be from our side that you have in the four corners ground control points, and also one in the center. This gives you for many adjustment options, which really make a lot of sense. We can see here there is not so much overlap between the images, so in drones typically you won't have this problem, but just to be aware again, if you place your ground control points, please don't put it into the last possible corner, even when we say place them in the corner. Of course, try to place them so they still have an overlap to the neighboring flight line or strip or whatever you want to call it. So the red ones, for example, you can see here in the bottom, they are in this overlap area to the next strip, and this is good. And the yellow ones, they are just in the last strip or a flight line measurable, which is not what we would recommend. In case your project is not a simple square or box, then in general the thumb rule is placing your ground control points along the border of your project. So just think about drawing a polygon at the outer bound of your project, and then you can then place your ground control points at these positions. So of course then you have not only 4 ground control points, but then you have multiple ground control points along the border, and then again placing one in the center helps then again here for stabilizing the block and also for the camera calibration. So here some example to try again for yourself to configure how would you now place for these flight lines. So each blue line represents one flight line of the drone, and so typically, of course, in a photogrammetric way, the solution would be typically we always say along the border. So if I would draw this polygon, but this is now really a lot, you would even, if in photogrammetry, if you want to apply for drift and shift correction, we would even need to add here a couple more ground control points. But this is of course too many ground control points for the workflow. So in this case, again, just think again about drawing your polygon and then placing here these polygons along the border. If you have some smaller parts, like for example here in the bottom we see these 3 strips here, it makes sense to place this ground control point here, mainly just to avoid that these strip here, or if there would be perhaps 4 or 5 here, that they don't have any reference. I mean, with the GNSS we have always a good stability, yeah, but this is really just to help us here to solve this. Or it's also possible that you extend your project area. That means in this case, if you would not fly here, always ending at your, perhaps you have a polygon given from your customer that says this is my area of interest. So if you would extend, for example, the flight lines, like for example here, we could again reduce the amount of ground control points drastically. Now we could even remove this one here, but this one helps us. Then we could make here, in case something goes wrong, here a sub block or a second project block. Or also we don't need this one here over here, so this is here too much. But this would then reduce our amount of ground control points just by extending our area. Or sometimes also it helps to have the possibility to easier place your ground control points. So for whatever reason, let's say here you are not able to place this ground control point here because there is some private area or a lake or something. So just by extending this part here, you can place it over here and then have it. Yeah, just imagine whatever. Yeah, it doesn't have to be perfectly here vertical behind this one. This could also be placed here. Just whatever helps you to make your block configuration easier and to place ground control points that can be good visible and also good accessible. Another topic that also is very often asked for is the corridor mapping. So when you fly a corridor, even it's lesser images, it's the more complex part of drone photogrammetry. So we really strongly recommend when you fly a corridor, please, if possible, fly 2 strips or 2 flight lines. So fly with your drone first along and then come back with your drone and fly a second strip which has overlap to the first strip, and just that these 2 parts can stabilize each other. Besides stabilization, it's also of course occlusion. So that means when you fly this way, you have more angles where you can extract information, where you can therefore also get your point cloud and measure afterwards your needed information. Also, when you fly along corridor, we strongly recommend to use GNSS. So flying corridor without GNSS is really not recommended, because then you would need to place many ground control points along your way, and I think nobody wants to do this. But if you don't do it, then you can have this bending effect like this bridge. So that means if I only have here at the beginning 2 ground control points and here at the end, we can have any effect in this corridor flight without seeing the problem. So this is really something strongly to recommend. Fly please with GNSS. Again, if you only fly with 1, then also the next problem is twisting. That means if I place my control points here, then you can twist your block and you would not see that there's a problem. So this is really something to be aware. So therefore, having your GNSS is like these 2 strips here on top of this bridge. They stabilize here, and then of course they would then be also needed to, with the GNSS, they would then pull them up and keep them straight. In some way, this would now be with low GNSS quality. So we have some stability, but this is really causing a lot of trouble if here the GNSS does not have the high quality. So therefore we want to have here a stiff and strong GNSS, I don't know how to call it, like a wooden pail that keeps us straight to it. Also, flying 2 strips has also so many benefits. So for example, when we take here this strip flown and we take then here a look from front, that means if I only have 1 strip, then the height is very well defined. But if I rotate, you see this yellow point here in the plane, this is my GNSS position. I can rotate the whole strip and still my GNSS fits perfectly. So that means slightly changes here can really cause trouble. So therefore, if you add then here to this a second strip, then let's add this here, second array, and then here, let's fly here with 70% overlap. So, and when we now take a look here, and when I now rotate, you see then my position of my second strip gets moved up and down. And of course, because I have this other position accurate also in centimeter accuracy, this won't happen. This is exactly what then will restrict in our adjustment, so that exactly this effect will not happen. So this is really something that helps us a lot. And again, just as I mentioned, if you place your control points here, then always place them here in the overlap areas of the part, and always as I call it twins. So when we take a look here from the top, then we would like to have these control points here, and then as a neighboring control point here, and then also here on this side, and then on the other side, but always being able to be measured in both strips, but still they stabilize it here. That means along this, so parallel to each other. So what we don't want are control points that you place just here along the center. So sometimes we see here people just place here along the center control points. And so they won't help us. Again, mainly the reason is because when we have them here, they should be here at the bottom, but just imagine these structures here on the ground. Again, if I rotate now here with this part and they are in the center, then we see in the center there's not much movement happening, first of all. And also if I would twist it, we would again, we could twist it here along this center part here, so along this area here. It's really easy then to have them, these ones here then rotated. The next topic we want to address is multiple flights. So you fly not only once with your drone, but you fly your first part with the drone, and then you come down, you change the battery, you fly your second part. So if you do this, you can also here make some planning that helps you in the afterwards. And this is that you, for example, try to fly the second part in the same direction as the first one, and to overlap the last strip to have here same content in it. Additionally to this, you place also control points along this overlap area. Perhaps not only 1 or 2, perhaps you make here 2 or 3 or 4 or 5 even, because then we could also, of course here you would again place here and here and here a ground control point in the corners, just drawing a polygon. And the same thing here, you would place one here, here, and here. But then we could also bring the block together. That means we could, if they are flown on the same day, if they have not strong illumination differences or occlusion areas because you flew it perhaps 1-2 weeks later and the vegetation changed, and because of the vegetation also the texture on the ground changed. But if this was flown perhaps on the same day, just 20 minutes later, then you could then also process them both in one part. This is using the merge functionality in TBC. But if not, if this is not possible because the drone was landing and the focal length during the landing changed because there was some movement in the drone and the camera, then we can still process them separately, and still, because we are using these control points here in the upper block and we use the same control points in the lower block, then the final results of these two, they will be homogeneous. That means we could then bring in, let's say, a point cloud from here and the point cloud from here, and they would still georeferencing wise fit. Or you have the orthophoto from here and the orthophoto from here, and these two orthophotos, they will also be homogeneous to each other. Because nobody in the end wants to end like this. This should be, of course, not our goal. Having two different flights, we still want that they fit to each other. And then also some general remarks, something to be aware. So another difficulty is when your terrain that you fly is very flat. And therefore, if you completely rely only on your GNSS, so this is represented here by this red box here. So this is the center of our camera. And when we now use just everything based on the GNSS, then there can also be some scale problematic, which means if I take here my focal length of my camera. So this is the GNSS position, and this is my focal length. And the problem is when I now take this focal length together with my terrain. So let's add my terrain here. And now when I scale this here, let's see it here, and you see they are together fitting to each other. That means I can scale, and because I scale, I change my focal length. And if I change my focal length, the focal length will still provide me a correct flat terrain on the ground. Yeah, so that means we, and this is also the problem also for the drones, that the focal length is unstable. Therefore, of course, we can still try to keep the focal length a restriction, that we don't change the focal length more than 10% or something like that. So this is something that really would make a lot of sense, but this can happen. That means if you have very flat terrain, because the focal length is calibrated, we need to calibrate it because the original focal length is not accurate enough to generate high precise results. And because we don't have any ground control points, then in this case here, it can happen that if we completely just base on the GNSS, that we get some scaling issues. So what helps us? Of course, one thing that we can have not influence, but if we have undulating terrain. Yeah, so that means if our terrain is not flat, but our terrain in this case has some differences in height, then of course here, again, if I would take here my focal length and my terrain, and if I now scale it, then you see that of course my scaling changed, but also the positions of these different heights. Yeah? If I look here from top and I scale it, then you see in the outer parts they are moving here further to in the XY position, and this will of course not happen because we have here tie points, and these tie points are measured here to these different objects in different heights, and because we have multiple measured points, they will then help us, because of course we don't have only on this position of the image taken, but the drone is flying and continuing, and so we measure from this part here also from other areas our tie points, and they will then take care that we don't have here these scaling issues. Another thing that you can do is having, of course, ground control points, because the ground control point will, in this case here, when I go back here to this part, and I will just here activate here one ground control point. Let me here take this off and just add one here. And of course, if I have here my ground control point and I have a flat area still, if I now scale this part, and you see then let's make it here, then we see the ground control point of course sticks to this part, and the ground control point would help us that we will calibrate the focal length correctly. That's something I always try to push. So to calibrate the length of the focal length, one single ground control point can already help us drastically, mainly because we have a high precision in our GNSS itself, and we have a high precision ground control point down here. That means this will help us to make the focal length calibration more reliable. Of course, we have many GNSS, so the GNSS itself with high precision covered all over the area will also of course help us with undulating terrain to calibrate the focal length very good. So no problem with this. And then finally, of course, the best part would be also having, again, like we mentioned here, having our GCPs over the area covered, and then also having the ground control points on different heights. So that means even if my terrain is undulating, also having the ground control points on different heights is extremely helpful. So this will also help us to make a very good camera calibration, and also in this case here, a block configuration that helps us to give our block a good stability. So therefore, let's also finish here with, I think, the important sentence and also with our first slide. Even if you fly high precision GNSS, we would still recommend you to fly with standard minimum block configuration, having 4 control points in the corners, 1 in the center. And as you know now, it would be great if these control points are not on the same height, if they are on different heights, and therefore they would help us additionally to calibrate our camera, our focal length very well, and also to help us also for a shift correction. I didn't talk about this here, but if the GNSS, which is now based on your base station that you have generated, and the ground control points which come perhaps from a previous project or are some reference ground control points existing already from your cadastral part, then there can also be a shift difference, and of course then including both informations, the high precision GNSS and the ground control points, will also automatically in TBC calculate a shift correction so that your GNSS and your ground control points fit perfectly to each other. And yeah, these two combinations are really what we would strongly recommend. And if you are really lazy, at least measure 1 ground control point, which helps us again for the focal length calibration in a very good way. So therefore, thank you for watching this video and have a nice good day. Goodbye.